There's a question in the Mathematics Standard 2, Year 12 book by Cambridge, and it's a great question on annuities. It says this: Angus is planning to invest into an annuity at the end of each year that pays 10% per annum compound interest. Use a spreadsheet to calculate the payment Angus needs to make to have $10,000 at the end of 4 years. If you look at the textbook, the method that they suggest you use is a formula in Excel, which is this PMT or payment function. The payment function has a number of variables inside it. First of all, you've got the rate. We know what that is, it's 10%. Then you've got the number of periods, we know that's 4. You've got the present value, which is to say, what do you start off with? Well, that's going to be 0. An optional variable is the future value, and in fact, we need that. We know that it's $10,000. And type is by default, I'm thinking probably 0. Payments are due at the end of the period, and that will be the case with this example. And the question, of course, is what do you do if you don't want to use Excel to solve the problem? Well, one way that you could do it is hack it in Google Sheets. If you use a Google Sheet calculation where you've got this formula here which says grab the initial amount here, which is 0, add interest to it, and then add the new deposit, and then if you recursively add that formula for the following years, and you keep going until you get $10,000 at the end, what you would do is realize that, you can muck around with this value here for the deposit. When you get $2,154.71, you've landed in Shangri-La. Could you do this without Excel or Google Sheets? If you think about it, at the end of the first year, they're going to give you interest on whatever you had as an initial value in the annuity. Now that number is going to be 0, but here we write the formula down anyway. So it'll be the initial value, and I've said V0 times 1.1 because that's the initial value plus 10% of interest. That's going to be 1.1. And then you're going to make a new deposit. At the end of the second year, they're going to give you interest on everything that you already had in the fund. And then you're going to make another deposit. At the end of the third year, they're going to give you interest on everything that you had, and then you're going to make another deposit. At the end of the fourth year, they're going to give you interest on everything you had, and then you'll make another deposit. Now, we know that all of that has to be equal to $10,000, so let's do some simplification. As I said, the initial value is 0, so this whole V0 times 1.0 plus D just resolves to D. Well, then what we can do is we have 1.1D, and if you keep going, 1.1D plus D is 2.1D, and so we have this expression. You multiply that by 1.1 and you're going to get 2.31D plus D. Well, that's going to be 3.31D times 1.1 plus D. It's going to be 3.641D plus D. And then you are left with this, 4.641D equals 10,000. Do a little bit of division and voila. And you come up within a fraction of a cent of the answer in the textbook. So it's possible, not fun, but it's definitely possible.